We're going to start talking about stereochemistry. And I mentioned this term before. You should have some frame of reference for what stereochemistry means. What we're talking about here is the structure or the shape of the molecule in 3 dimensions. Okay? And chirality is a really important aspect of stereochemistry. Chirality is this notion of handedness. So each of my hands is unique in the sense that they're not superimposable. They're not the same. If you look at your right hand and you look at your left hand, they are not the same. You can line up your thumbs and you can line up your pinkies, but you can see that you'll have 2 backs of a hand. So they're not identical. If you line up your palm and the back, so now I have a back of a hand and a palm, you can see that the fingers don't match up. So your hands are mirror images of each other. If you put your right hand into the mirror, it'll look like it's a left hand. They are very similar, but they are not the same. So this happens with molecules as well. It happens with atoms. So an atom can be chiral, but it also can happen with molecules themselves. And the key thing about them is that chiral molecules or chiral atoms are non-superimposable on their mirror images, what we call the enantiomers. So for example, this molecule that you saw on the very first slide is chiral. So it has these functional groups here. And if I put it into a mirror, you can see that I have my hydroxyl groups lined up, my chloride groups lined up. It literally is what the molecule would look like in a mirror. But if I now take this mirror image and I turn it around, so I just turn it around 180 degrees, it's still the same molecule, right? These 2 are the same molecule. They're just turned at a different angle. You can see I've matched up the H and the CH3, but the OHs no longer match up and the Cls no longer match up. And what that tells me is that the mirror image of this molecule is not the same as the molecule itself. Not all molecules are chiral. Not all carbon atoms are chiral. For example, in this diol down here, you can see when I look at the mirror image and I turn it around, everything does match up. Its mirror image is the same as it itself. So the takeaway here is that some molecules are chiral. Now the question about what are the conditions for chirality, since we can see that these 2 molecules, one is chiral, the other is not, the conditions, particularly for carbon atoms, is they have to have 4 different substituents. So I have 1, 2, 3, 4 different substituents. And it needs to be sp3 hybridized. Now, the fact that it's sp3 hybridized means it's going to have 4 substituent groups. Okay? It has to have 4 single bonds. It can't have any double bonds. And each one must be different. So those are my conditions for chirality for carbon atoms. Now, molecules themselves can be chiral, and typically they will have chiral carbons to thank for that. But it is possible there are certain molecules that are chiral without having any chiral carbons. Okay? Such molecules are beyond the scope of the exam. We don't need to talk about them. But it's also important to note in the reverse that just having chiral carbons does not make a chiral molecule. So there are certain molecules that are achiral. The molecule is achiral, even though it has chiral carbons. And we're going to look at some examples. Now, we've identified that the mirror image of this molecule is not the same as itself. Those are two different molecules. And so we need a way to distinguish them. They're going to have basically the same reactive properties. There's going to be almost no way to really distinguish them. So we need a way to actually distinguish them, at least on paper. And because they're not the same. And so a process for that, we call this assign and align. The first job is to assign a ranking to the substituent groups. And the second job is to actually align the view. So you're assigning based on atomic number. Okay. Technically speaking, it should be atomic weight. So for isotopes, the heavier isotope would be picked. But for simplicity's sake, and for your purposes in the exam, you can just think of this as atomic number. Higher atomic gets a higher rank. So chloride is a higher atomic number than any of the others, so it's number 1. Then comes oxygen, then comes carbon. Hydrogen is always going to be last because it's always the lowest atomic number. What if it gets a little bit more complex than what we've seen? That one was really easy, but what if I had something like this? H, I know there's going to be number 4, and OH. So the OH is going to be number 1, but who's 2 and 3? Well, I need to know more. What if it's something like this? One and this one. This one is bonded to 3 hydrogen atoms. This one is bonded to 2 hydrogen atoms and a chlorine atom. So the top one wins. It wins because as we move down the line, it was attached to the atom of the highest atomic number. So this one will be 1, this group would be 2, this group would be 3, and this group would be 4. Okay, now we've assigned the numbers. The next task is to align them. There's 2 ways that you can think about this. One is to actually think about the molecule moving in space and aligning appropriately. The other is to imagine yourself, and I prefer this one. Imagine yourself shrinking to be this big. And imagine yourself walking into the page, into the screen. And so you're right there, right where this eye is, and you just look to the left and imagining what you would see from that perspective. Okay? When you do this, what you want is to have the 3 primary functional groups, the 3 main functional groups. You want them pointing at you, all of them pointing at you like this, with the lowest priority functional group, in this case hydrogen, pointing furthest away. So it's pointing back, and the 3 primary functional groups are pointing towards you. When you're looking at it from that correct angle, you go 1, 2, 3, your primary functional groups. If they go counterclockwise, it is S, which is Latin for sinister, which is left. R is to the right. R is rectus, or clockwise. Okay. So here I can see I have 1, 2, 3. It goes counterclockwise. It is S. But it is important that you are looking at them from the correct angle. Because if you look at them from behind, it'll look like they're going clockwise, and then you would be misled. So, with that, let's try out this problem. Okay, so how many chiral carbons are present in the compound below? Well, we first need to identify which are the carbon atoms that are sp3 hybridized. That's the first condition they have to meet. So I've circled all of the sp3 hybridized carbon atoms. The next question is, how many of them have 4 different substituent groups? And the answer is none. They all have at least 2 identical groups. Here I have 2 hydrogen atoms. Here I have 2 hydrogen atoms. All the others have 3 hydrogen atoms. So none of them is chiral. So the answer here is A.
For most students, and maybe you too, the CARS is the hardest section on the MCAT. It may feel like it's one of the few remaining obstacles between you and the medical school of your dreams. But as you try to prepare for the CARS, you find there is a never-ending stream of conflicting tips, strategies, and plans, none of which seem to actually help or show any results. If you feel frustrated, overwhelmed, or lost when it comes to the CARS, if you're looking for a CARS expert who has helped thousands of students achieve their MCAT CARS goals, then you found your solution. Testing Solutions MCAT CARS Bootcamp. Founded by Nick Zahner, a current medical student at Stanford with a master's degree in philosophy of religion from Harvard, Testing Solutions' approach to the CARS is revolutionary. Testing Solutions CARS Bootcamp provides day-by-day, step-by-step instruction that teaches you the techniques that produce ultra-high MCAT CARS scores. Instead of wasting your time with the needlessly complex filler that other companies try to sell you, Testing Solutions' approach to the CARS is based on the principle of minimum effective dosage. There's no wasted time, just the minimum amount of effort that is required to get you the results you want. With over 500 4.5-star reviews on Amazon, Testing Solutions CARS Bootcamp is the most trusted, proven, and effective CARS course available on the market today. You will have access to Testing Solutions' 180 meticulously designed CARS passages, the largest CARS practice library offered by any MCAT prep company in the country. Our passages are regularly rated by users on Amazon, Reddit, and SDN as the most accurate non-AAMC CARS practice passages available, consistently rated higher than Exam Crackers, the Princeton Review, Kaplan, and Next Step. Unlike some companies who prey on pre-medical student fears by charging outrageous amounts of money for their mediocre at best practice materials and courses, Testing Solutions will always charge a fair price for an amazing product. Because after all, we're not like the other test prep companies. We're aspiring doctors just like you, only a little further down the path. Let us help you do what we've already done. If you're not happy with your CARS Bootcamp for any reason, we offer a 100% money-back guarantee, no questions asked. You've got nothing to lose and the CARS score of your dreams to gain. Don't be one of the people who write us each week saying they wish they had found our MCAT CARS Bootcamp sooner. You don't have to struggle with the CARS any longer. Sign up and get started today.